Welcome to Powertech Insights. In this tutorial, I will provide a comprehensive guide on fault finding and troubleshooting for a three-phase AC generator alternator. Let's get started. Safety precautions. To ensure safety, always verify proper grounding before testing. Use PPE to protect yourself, including gloves and safety glasses. Ensure that all safety protocols are in place, such as lockout-tagout and PTW procedures. These tests should only be carried out by qualified and/or experienced engineers who have received safety training on live equipment. All test instruments and their leads, connectors, probes must be checked to ensure that they are suitable for the voltage levels being tested and are in good working order. Never attempt to test a live generator without another competent person present to shut down the engine or switchgear as necessary. Ensure that the work area is safe. Other personnel in the area are advised of what you are doing. Warning notices and tapes are displayed to advise others of the hazards. Required equipment and tools. Digital multimeter for measuring voltage, resistance, and continuity. Clamp meter for measuring AC/DC current without disconnecting wires. Megger to check the insulation resistance of windings. 12-volt DC battery to excite the exciter rotor. Blocking diode to preventing reverse current flow. 220V AC to 110V DC power supply. The fault finding and troubleshooting of three-phase AC generator alternator. Fault finding can be simplified by breaking the generator down into 7 separate test areas. 1. The main stator windings. 2. The rectifier diode assembly. 3. The exciter stator for the exciter rotor. 5. The main rotor winding. 6. The AVR and control circuit. 7. The PMG, permanent magnet generator, if fitted. Part 1. The main stator winding. In this part, we will provide a comprehensive guide on fault diagnosis for the main stator winding. Let's get started. Stop the generator set and switch off engine control circuit. Follow lockout-tagout, LOTO procedure. Disconnect the AVR wiring. Replace the AVR with a 12-volt battery. Connect the battery to the exciter stator. Polarity must be correct. Check all wiring is safe and secure before running generator. Remove lockout-tagout, LOTO. Start the engine and check that the speed is correct within 4% of nominal. Check the output voltage across the main stator terminals with the generator running at NO load. Using a multimeter, check all 3 phases in phase to neutral. The voltage should be balanced and within plus or 10% of the nominal voltage level. If the readings are okay, this indicates that the windings and diodes are in good condition. Further insulation checks only are required. If the voltage readings are lower than -10% or unbalanced phases to phase, the following tests are required to identify the fault. Check all wiring is safe and secure before running generator. Start the engine and check that the speed is correct. All tests are conducted with the generator running at NO load. The first component to be checked are the main stator windings. Possible symptoms of a main stator fault. The output voltage will be unbalanced, phase to phase, or neutral. In single-phase connection, the unbalance should be checked from LL to center tap. When separately excited with a battery, the engine will be loaded by the short circuit current in the fault. If the generator is run for a short period, the fault area in the windings area will become very hot. This can be detected by hand or from insulation burning smell. Using a multimeter, check all 3 phases in phase to neutral. The phase voltages should be balanced within 1% of each other. 4 single-phase connected machines. Check for voltage balance from line to line and to center tap. Alternatively, open all winding groups and check individually. The next test is to check the winding insulation TO earth. The stator insulation should be checked with an insulation tester. The test instrument should be 500 or 1000 volts for low voltage generators. Disconnect the AVR completely before carrying out this test. Disconnect any connections from neutral to earth. For low voltage machines, up to 690V, the minimum insulation value is 1.0 megohm to earth or ground. Windings must be dried out if below 1.0 megaohm. Check. The output voltage from the main stator should be balanced and within 1% across phases. Check. With the 12-volt battery, the voltage should be within plus or 10% of the nominal volts. Check. Insulation to earth should be more than 1 megaohm. If above tests are correct, the main stator is O.K. If the output voltage is balanced phase, but is reading lower than 10% below nominal voltage, this indicates that there is a fault in the excitation windings or rectifier diodes. In next video, I will provide you a comprehensive guide on the next tests are required to identify the fault in the excitation system, starting with the main rectifier diodes. Note, frame-rate machines normally have a slightly higher no-load excitation voltage than UC and HC generators, approximately 14 to 18 VDC. The 12-volt battery may therefore produce slightly less than 10% below the nominal voltage level, which still indicates no fault found. Part 2. The rectifier diode assembly. In this part, we will provide a comprehensive guide on fault diagnosis for the rectifier diode assembly, fault finding and testing the rectifier diodes, stop the generator set, and switch off engine control circuit. Follow lockout-tagout, LOTO procedure. Remove the access covers from the air intake. Locate the main rectifier on the shaft. Possible symptoms: the symptoms of a diode failure. Diodes usually short circuit when they fail, but can also go open circuit if the solder connection fails with high current, usually if both positive and negative diodes are shorted. A self-excited AVR system may not build up voltage on run-up. If the AVR is PMG powered, the excitation protection will continuously trip off, with or without load, depending on how many diodes have failed. With the battery test, output voltage will be low or zero. This depends upon whether there are one or more diodes faulty. During the battery test, a short-circuit diode may become hot and open-circuit its solder terminal. Two short-circuit diodes across one phase of the exciter rotor, positive and negative polarity, may also overheat or burn out the exciter winding. Exciter rotor and main rectifier connections. Disconnect the 6 ends of the exciter rotor connections to the rectifier diodes. Checking the rectifier diodes. Switch the multimeter to the position indicating diode test position. With the positive test lead on the anode side of the diode, the meter should give a reading indicating electron flow. Reverse the multimeter leads so that the positive lead is on the anode side of the diode. The multimeter should now read OL, no electron flow. The positive plate diodes should give opposite polarity readings to above. A faulty diode will give a short circuit reading in both directions, or an open circuit reading in both directions. Fault finding, testing of a varistor. Possible symptoms of a varistor failure. The varistor is a transient suppression device and is designed to protect the diodes from high transient voltages produced by fault conditions. Failure of the varistor usually results in the device going short circuit. If the AVR is PMG powered, the PMG generator will force sufficient current into a short circuit varistor to make it fail catastrophically, explode. If the AVR is self-excited, the short circuit varistor will collapse the generator output voltage until the varistor is removed. The generator will operate normally without the varistor fitted, but the diodes are unprotected and may fail with the next transient fault surge. Checking the varistor. Switch the multimeter to position indicated for resistance ohm testing. The varistor should read infinity in both directions and has no polarity. A faulty varistor will be short circuit or burnt by fault current. Fault finding, testing the windings and main rectifier. Reconnect the battery, if disconnected. Run the generator at nominal speed and recheck the output voltage. If the voltage is within 10% of nominal, the fault is now corrected. Any fault found with the rectifier assembly should now be corrected. With a 12-volt battery, the output voltage from the main stator should be balanced and within 1% across phases. The voltage should be within plus or negative 10% of the nominal volts. Insulation to earth should be more than 1 megaohm. If above tests are correct, the main stator and rectifier are okay. If the output voltage is still more than 10% lower than nominal, but balanced phase to phase, this indicates that there is a fault in the excitation windings. Part 3. The exciter stator. In this part, we will provide a comprehensive guide on fault diagnosis for the exciter stator. Let's get started. Possible symptoms of an exciter stator failure. If the winding is open circuit, the output voltage will be almost zero, but there is still a small voltage produced by the residual magnetism. When separately exciting the generator with a battery, the output voltage will be almost zero, no excitation current into the windings. With a PMG-powered AVR system, shorts to earth in the exciter stator may also overheat the PMG stator winding. A severe earth fault may cause voltage instability and or AVR failure due to high excitation current. Fault finding and testing the exciter stator. Stop the generator set and disconnect the battery. Follow lockout-tagout, LOTO procedure. Check the exciter stator winding resistance against correct values in the generator O and M manual. Using a multimeter across the exciter stator leads X plus and XX negative. The exciter stator resistance is checked with a multimeter set on the ohm range. The correct resistance figures are given in the operation and maintenance manual supplied with the generator. The exciter stator insulation should be checked with an insulation tester. The test instrument should be 500 or 1000 operating voltage. Connect one lead to either X plus or XX lead and the other to any earth point. The minimum insulation value should be 1.0 megohm to earth. Part 4. The exciter rotor. In this part, we will provide a comprehensive guide on fault diagnosis for the exciter rotor. Let's get started. Possible symptoms of an exciter rotor failure. If the generator is still able to produce voltage, the D-C excitation across the exciter stator terminals will be higher than normal. With a self-excited AVR system, the AVR may be unable to build up voltage on startup from residual magnetism. With a PMG-powered AVR, a winding short may cause repeated tripping of the high excitation protection circuit on load. A winding fault is usually a short circuit across one or two phases, possibly as a result of two diodes shorting across one phase group. When separately excited with a 12-volt battery, the voltage will be lower than normal. Fault finding and testing the exciter rotor. Stop the generator set and disconnect the battery. Follow lockout-tagout, LOTO procedure. Visual inspection is required. Any winding or insulation damage is usually visible on exciter rotor end windings, burnt or blackened coils. Check the exciter rotor winding resistance against correct values in the generator O and M manual, using a multimeter across the rotor 3 phases U, V, and W. A low resistance bridge is required to accurately measure values below 0.5 ohm. The correct resistance figures are given in the operation and maintenance manual supplied with the generator. The next tests are to check the main rotor windings. Part 5. The main rotor winding. In this part, we will provide a comprehensive guide on fault diagnosis for the main rotor winding. Let's get started. Possible symptoms of the main rotor winding. A fault in the winding is always a short circuit within one or more of the rotor coils. This may not be visible, as the outer turns are cooled by the airflow and may appear undamaged. If the generator is still producing voltage, the DC excitation across the exciter stator terminals will be higher than normal. With a self-excited AVR system, the AVR may be unable to build up voltage on startup from residual magnetism. With a PMG-powered AVR, a winding short in the rotor may cause repeated tripping of the high excitation protection circuit on load. When separately excited with a 12-volt battery, the voltage will be lower than normal, proportionally to the percent of shorted turns. Fault finding and testing the main rotor winding. Stop the generator set and disconnect the battery. Follow lockout-tagout procedure. Disconnect one lead of the main rotor connection to the rectifier assembly. The main rotor resistance should be checked against values given in the operation and maintenance handbooks. The main rotor resistance is checked with a multimeter set on the ohm range. If the resistance readings are low, a further test to confirm results may be necessary using a more accurate low resistance bridge meter. Enjoying the video? Don't forget to like, share, and subscribe. Hit the bell icon to support Powertech Insights and keep learning with more tutorials. Testing the windings and main rectifier. Reconnect the battery if disconnected. Run the generator and recheck the output voltage. If all faults found have been corrected, the output voltage should be balanced and within 10% of the nominal volts. The final test on the windings is to check the residual voltage. Part 6, the loss of residual magnetism. In this part, we will provide a comprehensive guide on fault diagnosis for the loss of residual magnetism and how to restore residual magnetism. Let's get started. Possible symptoms of loss of residual magnetism. Loss of residual magnetism is a problem for self-excited AVR control systems only and prevents voltage buildup on run-up. Residual magnetism is stored in the exciter stator laminated steel core. Loss or decay of residual magnetism may be caused by long storage or reverse in polarity of the exciter stator. The self-excited AVR system relies upon residual magnetism. To begin excitation, voltages build up when the generator on initial start up. Permanent magnet generator. Powered AVRs do not rely upon residual magnetism for initial voltage buildup, as the PMG is a very powerful supply source, even at very low engine speeds. Fault finding for the loss of residual magnetism. Stop the generator set and disconnect the battery. Follow lockout-tagout, LOTO procedure. Check that the battery polarity is correct to the exciter stator. Leads X plus and XX negative. Reverse the battery polarity if incorrect, then disconnect. Enjoying the video? Don't forget to like, share, and subscribe. Hit the bell icon to support Powertech Insights and keep learning with more tutorials. With the exciter stator leads X plus and XX negative open circuit, run the generator at nominal speed without load. Check the output voltage across the AVR power supply terminals. The AVR requires a minimum voltage of 3.5 VAC to begin excitation build-up. If the residual voltage is lower than 3.5 volts, the residual magnetism must be restored. Note, the residual magnetism may be as high as 10% of nominal volts. How to restore residual magnetism? There are 3 methods to restore the loss of residual magnetism. Let's discuss them in detail. Method 1. Flash. The exciter stator leads with a 12 or 24V battery for 1 to 2 seconds. Run the generator and recheck the residual voltage, minimum 3.5V, to the AVR power supply. If this does not restore residual, try Method 2. Method 2. Run generator at NO load normal speed. Flash AVR terminals X plus and XX negative for 1 second until AVR fires and voltage builds up. Shut down set, then check if AVR builds up normally. If this does not restore residual, try Method 3. Warning: never flash an AVR without a blocking diode in the battery lead. Method 3. If the residual magnetism is totally lost, it can be fully recharged by flashing, with 110 volts DC from a 240 VAC supply rectified to half-wave 120V DC. Residual should be fully restored with 1 to 2 seconds flashing. This completes the fault finding on the excitation windings and main rectifier diode assembly. The AVR should now be reconnected and the generator run at nominal speed. Any further problems must now be in the AVR with a permanent magnet generator if fitted. The next test, check out the AVR supply circuits. Part 7, the AVR and control circuit and PMG. In this part, we will provide a comprehensive guide on fault diagnosis for the AVR and control circuit and PMG. Possible symptoms of AVR supply failure. High voltage. This may be caused by loss of signal from the main stator. NO voltage. This may be caused by loss of power supply to the AVR. Unstable voltage. This may be caused by loose wiring or corroded terminals from the AVR to the generator. Fault finding of AVR supply circuits. Run the generator. with a 12-volt battery connected to the exciter stator, and check the AVR supply terminals. Check that the AVR is receiving the correct power and sensing supplies. Enjoying the video? Don't forget to like, share, and subscribe. Hit the bell icon to support Powertech Insights and keep learning with more tutorials. AVR sensing and power supply from the main stator. Check all 3 sensing leads into the AVR using a multimeter on AC volts. The sensing and power supply should be half-line, line volts in series star. 4 single-phase and 240-volt 3-phase machines. The sensing and power supply should be identical to the line voltage. Also check supply at the AVR terminals to ensure continuity of wiring. AVR power supply, PMG. Dowel pin for PMG rotor location. Ceramic magnet rotor, highly magnetic saturated field. 8-pole rotor, 100 Hz at 1500 RPM or 120 Hz at 1800 RPM. Through bolt fixture to shaft non-drive end. Permanent magnet stator. Run the generator at nominal speed and set the multimeter to read A.C volts. Check the permanent magnet stator output voltage across the 3 input terminals to the AVR. The voltage across P2, P3, P4 should be 170 to 220 volts A.C and balanced across phases. AVR sensing supply, 6 ends out stator. Using a multimeter set on A.C volts, check all 3 sensing leads into the AVR. To ensure continuity of wiring, check the leads at the AVR terminals. The sensing supply should be 190, 240 volts, when the line voltage is at its correct nominal level. This is achieved by turns ratio of the sensing isolation transformer. Incorrect voltage levels could be caused by a transformer fault. Winding ratios are different for 480, 600, 690 volts primary input to supply 170 to 240 volts secondary into the AVR sensing input 6, 7, 8. This completes the testing of the windings, main rectifier, and AVR supplies. The final test is to check if the AVR is faulty. Testing the AVR. Check that the AVR is not being affected by adverse environmental conditions. Excessive temperature limits 40 degrees to plus 70 degrees C. Excessive vibration limits 50 mmSEC velocity at 2100 Hz. Excessive humidity limits 0 to 60 degrees C, 95%. If all operating conditions appear normal, the AVR should be changed with a new replacement unit. The defective unit can be returned to manufacturer for test and report. Being an encapsulated unit, the AVR is not reparable. This completes fault finding of 3-phase AC alternator. Any questions? In next videos, we're going to talk about complete AVR commissioning. Please stay tuned. Warning: always ensure that testing should be conducted by qualified personnel familiar with protection systems, and that all safety procedures are strictly followed. Attempting these without proper training and safety precautions can result in serious injury or death. Do not try this at home or without the necessary expertise. Powertech Insights is not responsible for any harm or damage caused by improper handling of electrical systems. Stay safe. Thank you for watching. Don't forget to like, share, and subscribe for more expert tutorials. See you in the next video.